Hello Chem 1. Today in 10.5 we're going to continue on with some stoichiometry and learn how to determine a limiting reactant. Let's get started. One question we try to answer with stoichiometry is, why do reactions stop? The reason that a reaction stops is because it runs out of one of the reactants. It runs out of something that's feeding the reaction. We can use a baking analogy to help us understand this. Let's say that I'm making cupcakes and I need the following ingredients: 1 box of mix, 3 eggs, some oil, water, and some icing. And I know that those ingredients will make exactly 24 cupcakes. And then I look in my pantry or refrigerator and I find 2 boxes of cake, a couple dozen eggs, and the rest of what I need. The question is, how many cupcakes can I make from these ingredients? In order to solve this, you have to look at what you have and how many cupcakes you can make based on the reactants or the ingredients that you have. And after you do that, you can calculate how many cupcakes you can make and how much leftover of the other ingredients you would have. We call these excess ingredients. So we just take a quick look at this example. We have 6 boxes of cake mix and it only takes 1 box to make 24 cupcakes. So 6 times 24 would tell us how many boxes of cupcakes we could make. We have 2 dozen eggs and 3 eggs makes 24 cupcakes. So you could see that 3 times 8, because that's how many times 3 goes into 2 dozen, would be how many cupcakes I could make. But if you look at cans of icing, 1 can of icing makes 24 cupcakes. We can only make 2 batches from these 2 cans of icing. And what that means is the maximum number of cupcakes we can make based on the ingredients we have is 48. Because once the icing runs out, the reaction or the baking is going to stop. So that means that the ingredient that caused me not to be able to continue is the icing, and we would have access of the other ingredients like mix, the eggs, and the oil. So now let's identify some terms. A limiting reactant is a reactant that runs out. It's the reactant that you're going to use up first. In the cupcake example, this was the icing. The icing was the reactant that caused us to stop the reaction. The excess reactant is anything that's not depleted or it's something that you have a leftover of. So for instance, you could put oil, you could put mix. There's a couple things that could go here in the baking analogy. The theoretical yield is the maximum amount of product that you can produce based on the reactants or ingredients that you have. In this case, the theoretical yield was 48 because we could make 2 batches of these cupcakes based on the icing, the limiting reactant. The theoretical yield will always be based on the limiting reactant when it runs out. So the theoretical yield in the cupcake example was 48 cupcakes. In the chemical industry, a lot of times excess reactants are used because they're cheap and they're easy to find. So we'll take a limiting reactant, something that's more expensive and scarce, and then we will use plenty of the excess reactant to make sure that that limiting reactant fully reacts. So how do we determine a limiting reactant? I'm going to let you read through these rules, but the bottom line is this. You have to do a stoich problem with every reactant that you know to figure out how much product you can produce with that reactant, and then that will tell you what's going to run out first. I think this will be easier to see once we do some examples, so let's get started with that. So here's an example. You can see that this problem is different because we have 5 grams of nickel and 5 grams of chlorine gas that are combining, and they're forming nickel chloride. Because I have 2 givens, it is not assumed which one is going to run out. I have to figure out which one's going to run out. So what I'm going to do is going to go from grams of nickel to my product, grams of nickel chloride. So a grams to grams stoich problem. Then I'm going to do a second problem, grams of chlorine gas to grams of nickel chloride. I need to figure out how much nickel chloride each of those reactants can produce. So here's the math that goes along with that. Notice we're dividing by the molar mass of nickel, we're multiplying by the mole ratio, which is 1:1, and then we're multiplying by the molar mass of nickel chloride. So 5 grams of nickel will produce 11 grams of nickel chloride if we have an excess of chlorine gas. But we only have 5 grams of chlorine gas. Divide by the molar mass, multiply by the mole ratio, times by the grams of nickel chloride, and I would be able to produce 9.1 grams of nickel chloride. Remember, you can only produce the amount that is the least. So this right here, this 9.1, that is our theoretical yield. Because I know now that chlorine will run out first. So that makes chlorine gas my limiting reactant, and that makes nickel my excess reactant. So really the only thing that's different here is you have to run through the stoichiometry twice and then identify your parts. Remember, the theoretical yield and the limiting reactant are always tied together. You can only theoretically produce the amount that the limiting reactant will let you produce. Here's another problem. We have 13.5 grams of hydrochloric acid and 14.8 grams of iron sulfide. We're going to combine those and produce hydrosulfuric acid and iron chloride. Notice that the question is specifically asking me about grams of hydrosulfuric acid. So that means we're going to take each of these reactants and find out how many grams of hydrosulfuric acid we can produce. And here's our problems. We have 6.31 grams of hydrosulfuric acid from 13.5 grams of hydrochloric, and then 5.74 grams of H2S from the iron sulfide. What does that mean? That means that this right here, the least amount, is my theoretical yield. It means my iron sulfide will be my limiting reactant, and then hydrochloric acid will be my excess reactant. So really this is just gram to gram stoich and then identifying parts. The next question we can answer from this is how to calculate the excess reactant. The way we do this is by finding how much of that excess reactant is going to be used with the limiting reactant. Once we find that out, we can subtract from the total excess reactant we have and figure out how much leftover we'll have. So we look back at our problem, we know that 14.8 grams of iron sulfide, since it's the limiting reactant, it's going to be completely used up. So we need to find out how much HCl will be used with 14.8 grams of iron sulfide. So we need to do a gram of iron sulfide to a gram of hydrochloric acid. And that would look like this. Look, we are going from here directly to here, grams to grams. So if we use 14.8 grams of iron sulfide, that means we're going to use 12.3 grams of hydrochloric acid. Notice our 2-to-1 mole ratio from our coefficients. As you can see, we were told at the beginning that we have 13.5 grams of HCl. Well, since we're only going to use 12.3 grams, we can subtract those and calculate that we have 1.2 grams of hydrochloric acid in excess or left over. The math for these problems you already know how to do. You know how to do a mass-to-mass stoichiometry problem. Now, though, we're putting it in context where you have to identify what's your theoretical yield, what's your limiting reactant, what's your excess reactant, and how you calculate that. This is a long process. It takes a while, and it takes a while to learn. Do your practice problems. Let me know if you have questions. Keep up the good work.